So these are the topics we're going to be looking at today, talking about the offset feature. And inside of that, we're going to see that there's three different options we want to focus on. One called the standard offset, and this standard offset is going to take either a surface or a solid face and offset that one surface or solid face some distance. Now, that sometimes has a geometric limit as to how far we can offset it. If we're thinking about taking a curved surface and offsetting it to the inside of that radius, we're going to notice that we really can't offset any further than that radius to the inside. Otherwise, that radius will go to a zero value on the other side. The surface will self-intersect, and that'll cause a failure. So if we do get into a situation where I want to offset to the inside of a radius by more than that radius value, the true normal to surface offset's not going to fit. That's geometrically impossible. But there are ways of approximating that geometry. So if I'm looking to offset to the inside of a radius by more than that radius, and I want to do kind of a combination of a scaling command where the radius doesn't go to zero and translation, then I can approximate the offset using this thing called a controlled fit or an automatic fit. We're going to see how those two approximation methods work when the true normal to surface doesn't fit, typically because you're offsetting to an inside of a radius by more than that radius value. Then inside of that offset feature are a couple additional options called an expand. What that's going to do is offset a surface or a face of the solid, but then it's going to make a continuous volume, either solid volume or surface volume, in between those two, from the original to the new offset. And then when you do that expand, there's also an option to include draft, where it'll take the sidewalls of that expand feature, add draft to them, so you don't have to come back and add that draft as a separate feature. Now, as Corrine mentioned, we're targeting a 45-minute presentation here. That's a rough estimate. Promise not to go over 4 or 5 hours here, but we'll kind of shoot for that 45-minute period. Now, when we're talking about the offset, we're going to see that there's a limitation here to selecting one face or one quilt. So the question is, what if you have geometry that's more than one solid face or more than one surface quilt and you want to offset it? Well, somehow I need to take that geometry and turn it into a single surface quilt. And one way to accomplish that is to select those individual pieces. Maybe you have several surfaces or several solid faces. You could select those while holding the control key. And then once you've selected those multiple faces, you can copy them, right-click and say copy, or do the standard Control-C shortcut to copy them. And then as soon as you've copied those surfaces or solid faces, come right back with the paste. And what that's going to do is create a new quilt on top of whatever you copied as a single piece. Then I'll be able to take that new single quilt that I just created with the copy, and I'll be able to perform those offset commands on that single quilt. Now, when we're doing an offset, we already mentioned that the offset might not go to the dimension you want, especially if you're trying to offset to the inside of a radius by more than that radius. So here's an example. If I start with that original green surface, the smallest radius on that surface is up towards the top of it. And if I were to go in and find what that smallest radius is, it's about 25. Now, we will take a look at this tool. If you want to know where the smallest radius on a surface is, on your analysis tab, there is a command here called a radius analysis, where you can pick a surface, and then Creo is going to identify where on that surface that smallest radius is and give us the value of it. That's what we're looking at in the dialog box, this radius analysis. And I can see by looking at that, the smallest radius on that green surface is right about 25. So if I offset to the inside by about 25 or less, I'm going to have what we call a perfect normal to surface offset, where that offset value is measured normal to the surface at every point. As long as I keep that dimension less than 25, I'm going to be able to have that true normal to surface offset. So question becomes, what if I want to offset by more than that? Well, geometrically speaking, it's impossible. But if I'm willing to vary the thickness a little bit or the offset dimension a little bit, if I'm willing to take a little bit of an approximation, then instead of doing the true normal to surface offset that doesn't fit, there are a couple ways to approximate this standard offset feature that we're looking here. So one of those methods is called an automatic fit. And as the name kind of implies here, Creo is going to automatically figure out how to position and scale that surface so you can have a bigger offset than what that minimum radius is. In this example, again, The new surface we're making is the smaller one to the inside. The original surface was on the outside, and that had a radius up on the top of about 25. So notice I was able to offset to the inside by a full 30, 5 more than that smallest radius. But it's not a true perfect wall thickness there, or an exact normal to surface offset. I switched it to this automatic fit, and this is an approximation. The way Creo actually approximates the offset here is it does kind of a combination of a scaling operation and a translation of that scaled surface to position it so it looks like an offset. Now, since it's doing a scaling operation instead of a true offset, if we scale geometry, that radius is never going to go to 0. So that's going to prevent us from getting a failure when I offset by more than the wall thickness. Now, what I might not like about this automatic fit is how Creo takes that scaled surface and translates it into position to look like an offset. When I do this automatic fit, one thing I'm going to notice is when Creo does the scaling and the translation of that new surface on the inside, it's going to shift it down a little bit lower than I want to. If you look at this middle picture here, you can see the original surface has an endpoint that's a little bit lower than the endpoint of the original. I should say the offset surface is the new one on the inside. So that automatic fit is going to create that kind of taper at the bottom, or it's going to lower the offset surface further than I wanted it to. I want those endpoints to line up horizontally there. So if you don't like how Creo positions the scaled down surface when you use this automatic approximation, then there's a second approximation called the controlled fit. With the controlled fit, as the name implies, you have a little bit more control over to how Creo is going to translate or position that scaled down surface. So in this example, I didn't want it to do that offset in the Y direction, or that translation in my vertical Y direction here. So I went to my coordinate system. If I uncheck the translation in the Y direction, then it's going to look like the right-hand picture. As soon as I ask the computer not to translate in that vertical Y direction, then these 2 points at the bottom are going to line up perfectly. So that's the order in which I would try the standard offset feature. The default is the normal to surface, and that gives you the true perfect offset, normal to the surface at every point. If that doesn't work, typically because you're offsetting by more than the radius, then I would switch it to the automatic fit. Take a look at what Creo does, and if you don't like how it's scaled and positioned that offset surface, switch it from the automatic fit to the controlled fit. Then you have the ability to turn off the translation in certain directions, and at that point, you might get a surface that you like. Now, when we're doing this standard offset, Creo is going to have you pick one quilt. Now, in my example on the left, this quilt that I'm selecting happens to have about 8 surfaces inside of it. I actually don't want to offset the entire quilt. What we're going to notice when we go to pick the geometry that we want to offset, you do have to start by picking the entire quilt. But then, once you get into the offset command, there is going to be an option to exclude certain surfaces out of the quilt. So I start by picking the entire quilt that I see on the left, start this standard offset, go to the exclude option, where I can ask the computer to exclude those 3 bigger surfaces in the middle, and then my resulting offset is just going to contain the rest of the quilt that I didn't exclude. So although you have to start by picking the entire quilt, inside of the offset feature itself, there's an option to exclude. Now that standard offset that we were talking about allows you to take a solid face or a quilt and offset at some distance, either with normal to surface and the approximation with the automatic fit and the controlled fit. There's another option inside of the offset. The first icon here is that standard offset that we were just talking about. There's another icon called an expand. Similar, but does something different. So the expand, again, is going to take a quilt or a solid face and offset it, but then it's going to make a continuous volume between that new offset and the original position. If you're offsetting a solid face, it makes a continuous solid volume between the two. And then if you're offsetting a quilt, a closed quilt, it's going to make a continuous surface between the two. So here's an example of a solid model. So even though this feature is called a surface offset, we can apply it to solid geometry, where I'm taking that right-hand face of the solid, that concave face, and I want to offset it to the right, but add solid geometry between them. So I pick the right-hand face of the solid geometry, go to this offset feature, and then switch it from the top icon, the standard, which is the default, into this one called an expand. Then I just tell the computer how far I want to expand that. Here I expanded it 7 units to the right, and now I get a new solid shape that's 7 inches bigger. Now, if we look at our actual geometry here, let's say that original surface had a radius of 10. When I offset that 7 units to the right, that new surface is more curved. So if the original surface had a radius of 10 and I offset by 7, that new surface is going to have a radius of 3. So maybe that's not what I want to do. Maybe I want to keep the original surface shape exactly the same, and instead of offsetting it, where that radius gets smaller by the offset distance, maybe I just want to move it. Maybe I want to take that original surface and just slide its shape to the right. There's an option, instead of offsetting with this expand, to do a translation instead. If I do the translation, then it's going to take the current shape of that surface, just move it to the right, and fill in with continuous solid volume between the two. So this is what it would look like if I do the offset. That would be the default. Then if I go to the options menu and switch it from a normal to surface offset to the second option called the translate, now it's just going to take the original shape, which is the cyan colored surface here, and it's just going to move that original shape. When you do the translate, the computer is going to ask for a reference. It's going to ask, what do you want to translate along? You can either pick a linear edge and it'll translate parallel to it, or you can pick a plane and it'll translate normal to the plane that you pick. So this is what it would look like if I switch it from a normal to surface offset into this translate option. Again, that's all part of the expand. Now, when you're doing an expand, you can take a solid face or a closed quilt and you can expand the entire surface like we were doing in that previous example. However, you can also expand just a portion of the surface. Here, I started with the big cylindrical shaped surface, selected that, went to my offset, switched it to an expand, but now I only want to expand part of the surface. So you can see there's an option under options. Instead of offsetting the whole surface here, I can go to this sketched region. Then I'm going to make a sketch on a plane, and then Creo is going to take the geometry inside of the sketch and only offset that. Here I drew a rectangle as the sketch, and now I can see it's only offsetting a portion of that cylindrical shaped surface. Now, when I do the offset, I have a choice as to what the sidewalls of the offset are going to be normal to. Now, the option called surface is going to make the sidewalls of the offset normal to the surface that you're offsetting. Again, the surface I'm offsetting is this cylindrical one right here. And then I can see the sidewalls are normal to the surface itself. Now, the plane that I drew the sketch on was running horizontal in this view. So if I switch this option and ask Creo to make the sidewalls of the offset normal to the sketching plane, then you can see the sidewalls are perfectly vertical. I didn't show the sketching plane, but in this view, the sketching plane would have been running horizontally. So you do have a choice as to what it's going to make the sidewalls of the offset geometry normal to. Either the surface you're offsetting or the sketching plane of the region that you're offsetting. Okay, now there's even another option in this offset feature. There's the expand that we were looking at, where Creo takes the face, either offsets it or translates it, and then fills in with continuous volume between the two. Then there's another one called an expand with draft. This icon here. The expand with draft is going to do all of the expand things we looked at, but then also add draft to the sidewalls of the expand. So here, notice in the bottom picture, I set this to have the sidewalls normal to the sketch, which is this horizontal sketch. But notice they're not. The sidewalls are actually tilted in 10 degrees from that because I'm using the offset or the expand with draft, and I put in 10 degrees as the draft angle. So if you want to include taper or draft as part of the expand, you use this icon called expand with draft, then you just type in the draft angle that you're looking for, and it's going to go in and taper that geometry. Now, when you are using the expand with draft, besides being able to add the draft, there's a second option. It's only available with the expand with draft, and it's going to allow you to make the sidewalls all tangent to the original surface and the offset surface. So instead of having the sidewall straight, if you do the expand with draft, there's a second option called tangent. And then I can see it took the sidewalls and it made them tangent to both of those surfaces. It actually curved those surfaces. So that's the offset feature. There's the standard offset that can be approximated if it doesn't fit with the automatic fit and the control fit. Then there's the expand that either offsets or translates the surface and fills in with continuous volume between them. And then if you want that expand to have draft, there's the third one called an expand with draft. So all looks like that. Now, to see this in the actual software here, let's go into our Creo session. and take a look. Now, since we're talking about surfaces, I have to show you one thing before we do any of our offsetting. There's a technique in Creo, and it's almost kind of a secret. If you know the secret, this will be obvious. But if you're in a situation where you want to pick or select a bunch of adjacent connected surfaces, there's a very handy, powerful tool that picks a bunch of connected adjacent surfaces for you. But Creo never really tells you this is available. You just have to know what this technique is. So let's say in this model that I want to pick all of the inside surfaces of this container for whatever reason. Maybe I want to copy them or offset them or change the color of them. Anytime you get into a situation where you're looking to pick a bunch of adjacent connected surfaces, there's a tool for picking those called the seed and boundary. Now, to use this seed and boundary, there is no command that you start. You don't have to go to a menu pick or an icon. All you have to do is go to your model and pick one surface. Pick one of the surfaces that you're trying to select. That first original surface is going to be referred to as the seed. In this process, Creo is going to pick the seed surface that you select, but it's also going to select all the surfaces that touch the seed and all the surfaces that touch that bigger set, up to, and not including, a boundary surface that you pick while holding the Shift key. So for the inside of this model, there's about 200 surfaces here. I want to pick all of them. Now, if I feel like wasting a lot of time, I could hold the Control key and try to pick all 200 of those surfaces individually. But since they're all connected, this seed and boundary is going to be way more efficient. So what I'm going to do is pick any one of those inside surfaces as my seed, maybe this one. Then what I do is hold the Shift key, not the typical Control key, but the Shift key. And as I'm holding the Shift key, I pick all my boundaries. Creo is going to pick the seed, the green one I started with, everything that seed touches, everything that bigger set touches, up to and not including the boundary you pick. So all those inside surfaces in this model are bounded by one surface. All I have to do now is hold the Shift key, pick this top surface right here. Then as soon as I let go of the Shift key, Creo picks the seed, everything the seed touches, everything that set touches, up to and not including the boundary. So with just 2 mouse clicks, I was able to pick all those interior surfaces. Let me show you again. So maybe I pick this one as the seed this time. Really doesn't matter. Hold the Shift key, pick this as my boundary, let go of the Shift key, and it picks all those surfaces. Now, of course, depending on your geometry, you might need more than one boundary. Let me bring back a little cut that's in the sidewall here. I'm going to take this extrude feature, resume it. So now, if I'm trying to pick all those inside surfaces, I actually need 4 boundaries now. I would need this surface as well as the 3 surfaces of my little notch here. I'd have to pick all of those as my boundaries. So to do that, I just pick 4 boundaries in this case. So I'll start with this surface. Maybe I don't notice the notch. So I pick my seed, hold the Shift key. Maybe I think that's enough for my boundary. Then when I let go of the Shift key, I notice it winds up picking the outside surfaces. The seed grows through the notch, which is connected, and connects to the outside of the model. If you miss a boundary, you don't have to start over. So I now see that I missed 3 boundaries. I don't need to do the process again. All I have to do is go back to the Shift key. Since I missed 3 boundaries, I just go back to the Shift key on the keyboard, which I'm doing, and now the computer is going to let me pick additional boundaries, like this one and this one. Now, maybe I want to spin to pick that hidden boundary. I can't do that while I'm holding the Shift key. So what I would do is let go of the Shift key, ignore what it did, spin the model, go back to the Shift key, pick my 4th boundary, and now that I have all 4 boundaries selected, I let go of the Shift key, and that seed and boundary picks all those interior surfaces. That's useful anytime you need to pick a bunch of connected surfaces, whether you're trying to copy them or offset them or change the color of them. Maybe in this example, I selected them because I wanted all the inside surfaces to be brown. Now I have those guys at brown. So that technique is going to be useful for lots of things inside of Creo. We'll use it in a couple of situations when we start talking about this offset feature. So to look at the actual offset feature, let me go to a model where I've created a surface with some sort of complex curvature to it. And now I'm looking to take that surface and make a new one, offset to the inside of it with a true normal to surface offset. So to offset a surface, pick the surface you want to offset like this one. The offset icon comes up in your mini toolbar. It's right here. Also in the ribbon on the model tab, the offset icon is up here as well. You go to the offset, and then I can see the computer takes the original surface, the green one, and now it's making an offset. For the offset value, I can type it in or I can drag it. Now I want to go a little further to the inside. So I can take that yellow dot and I can start dragging the offset distance. And notice, oops, I lost it there. So once I hit a certain number, the preview disappears, and that's an indication that the offset's no longer working. The surface is failing. So if I drag that offset back shorter, I can see that it works at 100. I can go a little past 100 if I go slow here. So I can get it up to about 105 or so, and then right around 105, 106, it fails. So I'm wondering, okay, why does it not work at 112? Like, what's the limiting factor? I can expect it's the lowest or the smallest radius on that surface, but maybe I want to be able to see where that is. Maybe I want to be able to visualize where the problem is. So there are a couple of analysis tools that'll come back and really tell us what the maximum offset value is going to be here. A good tool for seeing what that maximum offset is on the analysis menu. You have this tool called the radius. That's where you can pick a surface, and then Creo is going to find the smallest radius. And that's really the limit as to how far I can do that true normal to surface offset. If I go to this radius command here, this box comes up where I can pick this surface, and the computer's telling me in this direction the smallest radius is about 106.7. So that's really the limit. I can offset it about 106.7, but no further than that. And we saw that as we were trying to drag our offset. So I know what the smallest radius is, but maybe I want to more clearly visualize where the problem is. If we're doing an offset and it's failing, there's a pretty handy tool for being able to see exactly where the problem occurs and what's happening with the shape of the model. There's another tool. So now that I know that the maximum radius is about 107, there's another tool here called offset analysis. So what that's going to do is allow me to offset past that smallest radius where I get a self-intersecting surface, and it'll actually show you the self-intersection on the surface. Whereas the offset feature wouldn't do that. The offset feature won't show you the intersection. It'll just fail and show you no geometry at all. So if I go to this offset analysis, I can now pick this surface. It's going to put a grid on it. Now, to make the grid lines a little finer, let's bump these numbers up just a little bit bigger here. And now as I take that offset surface and start increasing the offset distance here, let's put that in at about 30. So I can look at the surface, and looking at the grid lines, I'm just looking to see if any of them cross. So I don't see any self-intersection. I know that 30 dimension works perfectly fine. Actually, I can go all the way up to about 107. Now, as I drag that offset value up further, I can see that the surface is starting to close in on itself back here. Actually, it already has. So as soon as I hit that 108, I now have a self-intersection on the back. Let's spin this around. And if I zoom in right in here, sometimes you have to spin and zoom, I can see I now have a self-intersection on that surface with the offset at 112. So that's why I can't go any further than that 106 dimension. Of course, if I extend it out even further, then I have a bigger and bigger self-intersection. Now, the computer would not show you that shape right there if you were in the offset feature. When the offset feature fails, it doesn't show you any geometry at all. But this offset analysis is able to show the self-intersecting surface. So this can be a very powerful tool for figuring out why your offset fails. If I was looking to go at 170, I know that doesn't work. Now let's go back to a value of about 80. So I'm wondering, if I go in and change the shape of the green surface, is my offset still going to work at an 80? Well, what I can do now is save that analysis. I can keep that red mesh surface up on the screen. I can then go in and manipulate the shape of the original surface, and that mesh is going to update right away. So as I'm visually dragging things around on the screen, I can keep an eye on that offset mesh and see if I cause a self-intersection, which would make a failure. So I'm going to ask the computer to save this analysis, that red surface up there. Then I think I'll take a sketch on the blue part here. I'll take this sketch, edit the dimensions on it. So I'm going to change the shape of that surface. Happens to be a boundary blended surface. So as I start manipulating this spline curve to change the shape of the original surface, I'll notice the offset mesh updates right with it. And if I make that change, I can see I caused a self-intersection right here. So by changing the original geometry, I can keep an eye on the mesh and basically know whether the offset of 80 that I typed in is going to work in the model. In this case, no, because I can see that self-intersection. Now, let me undo that modification. I'm going to put the part back the way it was. And now I don't really need to see the red surface anymore. I'm going to go to my saved analysis up here, pick my analysis, hit that minus sign to delete it, and get that out of the way. All right, now let's look at a limitation of what you can pick. Now I saw I could only offset by about 106 because of that smallest radius. Let me bring back another surface. I have a hidden surface in this model. Let's unhide that. Maybe I want to offset that entire shape. What I could do is put my selection filter on quilts here. Let's grab that surface or quilt, hold the control key, pick this one, because I want to offset both of them. But notice I can't. When I go to the model tab here, I can see the offset feature is grayed out. And the reason for that is I selected more than one quilt. Or if you select more than one solid face, it's going to come back and say that that is not an option. So I can offset that shape. I can, but I can't offset it by selecting two individual quilts. I need to pick one quilt. So in this case, I just need to take those two separate quilts, merge them together into one single bigger quilt, then I'll be able to do the offset on that one quilt. To merge two quilts together, pick one, hold the control key, pick the other one, go to this icon called the merge. I can ask the computer to join those two surfaces together. Now I have a single quilt. So if I go in and pick that single quilt, I can do an offset. Here's the icon in the mini toolbar. Maybe I offset it about 30, finish the offset, and now I can see I have a new surface offset about 30 from the other one. Now there is another option in that standard offset that we did here. I can ask the computer to make the side surfaces. And then what that's going to do is make a bound volume or a closed volume. It's going to make the surfaces, like the 30 millimeter tall ones, around the outside. So the result is a closed surface when I'm done. Let's go back to this offset here. I'm going to edit the definition of it. Look under options, and I can see I have an option to create the side surfaces. So that makes the offset and all these thin side surfaces. Now, one thing that's a little unusual here is although that geometry was all made with one offset feature, Creo does not merge the offset with those side surfaces. So notice the side surfaces are one quilt and the offset face is a separate quilt. Normally when you produce a feature in Creo, all the geometries merge together. But in the case of this standard offset where you make the side surfaces are not merged in. So if I was looking to turn that shape into a solid, I have three separate quilts. Well, to make a solid out of that, I need to get those three separate quilts merged together. Then I can use this solidify feature to make it a solid. Let's take the side surfaces that standard offset feature made. I'll hold the control key, pick the offset surface itself, go to my merge command. I can ask the computer to join those together. Then the original surface is still separate. So I'll pick that original surface on the bottom, hold my control key, pick the one I just merged together, do another merge, ask the computer to join those. So now I have a single closed up airtight surface or quilt that I could fill in with solid. If I want to make that a solid part, I could take that closed quilt, hit this solidify feature, ask the computer to add material or fill with solid, hit the green check mark, and now I actually have a solid model. If we wanted to look inside of that, we could cut ourselves a cross section here, maybe color that surface. And then if I drag the cutting plane through the model, I can see, yes, the whole part is solid. Now, is that a good way to make the model? If that's what I wanted in the end, actually, there's a much more efficient way. So notice what I did here is I made an offset surface with the side surfaces. Then I had to do a couple merges. Then I did a solidify. I did a total of 4 features to accomplish that. There's actually a way to make that shape with just one feature. Instead of doing the surface offset, there's a very similar feature that does basically the same shape, but it makes a solid right away. Instead of doing the surface offset, there's a command called the thicken. So if I was looking for the solid geometry that I have here, a much more efficient way to build that is not to do the offset, the 2 merges, and the solidify. I'm going to take all 4 of those features, delete them. The faster way to get that solid with the constant wall thickness is to pick this quilt and go to a different feature instead of the offset. If I go to this feature called the thicken has exactly the same options that the offset does, but the difference is the offset just produces the surface geometry, whereas the thicken produces the same surface, but then fills in with solid material right away. So if I go to this thicken command, all I have to do is type in my 30 millimeter thickness, and with one feature, now I have a solid shape that looks like that. So what we looked at there was the standard offset feature. Let's look at another standard offset that really doesn't work the way I want it to. So here's a model. It's a little plastic cover. If you know what this is, you played with electronics probably back in the 80s. one of those little portable CD covers. So on this model, it's a surface model, and I want to turn it into a solid. So I want to thicken it. But before I even try that, let's look at that radius analysis and see what the minimum radius is. Back on the analysis tab here, I can go to my radius command. I can pick this quilt, and the computer's telling me that that minimum radius on the inside is a 0.5. Little bit of a problem. I really want my wall thickness at a 0.6. So according to this, that's not going to work at that 0.6 thickness that I want. So whether I do a standard offset or whether I do a thicken, that 0.6 dimension should go past that radius and cause a failure. So knowing that, I'm going to try it anyway. I'm going to put my selection filter on quilt here. I'm going to select this quilt, and I want the solid right away. So instead of doing the surface offset, then merging it, then doing a solidify, I'm just going to go right into the thicken command here and ask the computer to apply a wall thickness. I want the wall thickness on the inside. I need to flip this arrow. Then for the wall thickness, I wanted that 0.6 dimension. Now, let's go ahead and try and finish it. I'm going to hit the green check mark, and this is one of my favorite messages in Creo. So it comes back and says, feature could not be created. The next sentence is my favorite. So it says, do you want to create the feature successfully? I always want to create my features successfully. So if I say yes, the computer's going to fix all my problems and give me a perfect model. Actually not, but if I do say yes, it will prevent the feature from failing. It's not going to do what I want it to, but when I say yes, what the computer did is it took all the surfaces that had a radius of less than 0.6 and it didn't thicken them. It just left those out. So looking at this model, it kind of sort of looks like it's okay, but when I hide those original surfaces, I'm going to see the solid geometry that I just produced has a bunch of holes in it. So when Creo asked that question about fixing it, what I allowed it to do there, when I said yes, is I allowed it to exclude all the surfaces that had too small of radius. And that's why I'm getting all these holes in my solid. Not at all what I wanted. So what I'm going to do is try those approximation methods. Since the true normal to surface offset doesn't fit at that dimension, I went to the inside by more than the smallest radius. I'm going to try those approximations of the automatic fit and the controlled fit and see if I can get an approximate wall thickness that looks good enough. I'm going to edit the definition of the thicken here, go back into that particular feature. And now when I go under options, instead of the true normal to surface, where Creo had to exclude all those orange surfaces and make a bunch of holes in my part, I'm going to switch this to the automatic fit, where Creo is going to automatically do more of a scaling operation, a scaling and a translation, instead of a true offset. So when I go to the automatic fit, it now includes all the surfaces, the whole model solid, and when I hit the check mark, it looks kind of okay here, but let's bring up a cross section. I do have a full solid model. What I'm not going to like is how it did one of the translations. If I bring up cross section A here, maybe zoom in on this corner, it created kind of a slanted surface or a big bevel across the bottom. I don't like that big slant down there. So what I'm going to do is get rid of this automatic fit where I don't like how it translated in that direction and created that big taper. I'm going to switch it to a controlled fit and see if I can prevent it from angling that surface. I basically want that surface to remain horizontal. So to do that, we're going to go back into our thicken here with edit dimension or edit definition. Then under options, we're going to try the controlled fit. And if we look at a front view of the model here, what I don't want it doing is shifting like this. So I'm going to turn off the ability to translate in this vertical Y direction relative to this coordinate system. I just uncheck the Y direction translation, and now I have a good shape. So it's not beveling the bottom anymore. And finally, I was able to offset by more than the wall thickness without getting a failure or that beveled surface. That's really the order in which you want to try the offset. Let it default to the normal to surface offset where you get the true perfect offset. If that doesn't work, try the automatic fit. If that works, great. Creo automatically fixed your problem. If it didn't, then you might go to the control fit where you can ask the computer not to translate in certain directions. So that was the standard offset. Let's look at the expand. The expand is going to take a surface, or in this case, a solid face. It's going to either offset it or translate it, and then fill in with continuous volume between the two. So maybe I'm looking to take this surface, pull it out to the right, adding additional solid in between the new surface and the original. Before I do that though, let's just look at the radius of that surface. So I can see that surface has a radius of 16. So if I offset that to the right, that radius is going to get smaller by the offset distance. Keep that in mind. So to offset that solid face, I grab that solid face, go to this icon to start an offset feature, and the offset starts with the standard offset, where it's just taking the one green surface and offsetting it to the right. I want to switch that to the second option called an expand, where it's then going to fill in with continuous volume between the two surfaces. Instead of a standard offset, I'm going to go to this icon called an expand feature, and now I can see it's adding solid material between the two. And as I drag that surface further to the right, notice the radius keeps getting smaller. This surface keeps getting more curved. Now, the original width of this part was 16. The original radius was 8. So if I offset by a value of 8, this is going to turn into exactly half of a cylinder. And that's where I hit the limit. As soon as I hit that half cylinder shape, I can't go any further. So as soon as I get this guy out, right, to a value of 8, the 8 will work, and I get a perfectly sharp edge there. Like that's a knife edge. But if I try to go any past 8, it's going to, curve back in on itself and fail. So if I drag that out just a little bit further, I can see I get a failure. So let's try a value of 7, which works. Now remember, the original radius was 16. I just offset by a 7. Anybody quick with math? So what's 16 minus 7? So that radius now should be 9, which it is. Okay, now maybe I don't want that radius changing. Maybe I was more interested in just taking that original shape and moving it to the right, or translating it instead of doing an offset. If I translate, then there's no limit as to how far I can go. Since I'm not offsetting, I'd be able to translate that as far as I want to go. Let's grab that same solid face, go back to that offset again, switch it to this option called an expand. Now, instead of offsetting the shape to the inside, I can go under options, switch this to the translate option, and now Creo is going to ask for a reference. So what do you want to translate parallel to, like a linear reference, or what do you want to translate normal to, which would be a planar reference? I'm just going to grab this linear edge and translate parallel to it. Now for the translation, I'm free to go as far as I want because it's not changing the shape of the surface. The translate is just taking the original surface, the cyan one there, and translating it parallel to that green edge. So I'm free to translate as far as I want to. That's the expand command. The expand is going to offset the surface and then fill in between them with solid material. Or in this case, it's going to translate the surface and then fill in between them with solid material. Now, when you're doing that expand, you don't necessarily have to expand the entire surface like we did here. There's an option called the sketched region where you draw a sketch and then Creo is going to do the expand just inside of the sketch. Let's go to another model, a surface model this time, where I have a surface with complex curvature, happens to be part of a torus here. And now I want to offset part of the surface within a sketched region. So I'm going to grab that surface, go to this icon here called an offset, and then instead of offsetting the entire surface, we're going to switch it to an expand with this icon. And then under options, I can see there's an option to expand inside of a sketched region instead of expanding the entire surface. So I'm going to hit define to make a sketch. Let's draw the sketch on this datum plane up here. We'll have that plane face to the right. And now in my sketch view, I want to draw an elliptical shape. Let's lose the shading, and we're going to do a centered ellipse. Oh, about like this. There's an elliptical shape. Let me get some exact numbers. Let's make it 275, 175. Here's the 3D view of that sketch. So now the computer is going to project that sketch down onto the surface and then do the expand only inside of the sketch. It's going to expand part of the surface. So I go ahead and finish that sketch, and then I can see my expand feature is expanding just inside of that sketched region. Let's look at a 2D view here, a front view. And I can see in the front view, it's making the expand, and these side surfaces of the expand are normal to my sketching plane. There is a second option. I can have those side surfaces normal to the surface I'm offsetting instead of normal to the sketching plane. That option is under options, and I can switch that to surface here. So now I can see the sidewalls are normal to the surface that I'm offsetting instead of the original sketching plane. Now, another thing I can do is an expand that includes draft. Let's put this back to normal to the sketch. If I want this to be tapered and not offset nearly as far, then I can switch to another option called an expand with draft. And now the computer is going to allow me to apply draft. The draft angle is at 0 degrees. So right now, the sidewalls are normal to the sketching plane. But if I wanted to tilt those in 30 degrees, I can apply 30 degrees of draft. Now my expand feature is drafted. Now, of course, you could do the expand without draft, come back and add a separate draft feature, but you do have the ability to include draft right as part of the expand operation. Now, another thing I can do when I expand with the draft is the with draft option, only that one, has this option to make the sidewalls tangent to both surfaces. So when I ask for the sidewalls to be tangent, now you can see it curves all the geometry looking like that. So let's go back to surface here. Let's put the draft angle at about 35 degrees. Let's do 40 degrees. And then for the total height of the offset, let's come up just 15. So there's the final shape I'm looking for. That one's called an expand with draft, where we expanded inside of a sketch, we drafted the sidewalls, and then I asked the sidewalls to all be tangent. And that's what gives us that curve shape on the sidewalls. So shape like that. Now I want to do another one. I now want to take that surface and expand a sketched region inside of that one. So we're going to grab that surface, go back to the offset feature, switch it to our expand, which is this icon here. Then we can do an expand inside of a sketched region. Now, when I go to set up the sketch, I want to sketch on the exact same plane I did the other one on, or the previous feature. So I don't even need to pick the plane again. If you want to draw a new feature on the same sketch setup as the previous one, there's a button here called Use Previous. That's what I'm going to do to set up my sketch. And now the sketch I'm looking for here happens to be a couple shapes that are on that sketcher palette. When you're drawing sketches in Creo, if you want some sort of common shape, you might not have to draw that from scratch. There's about 50 or so common shapes built right into the software. So if I go to my sketcher palette, I can bring up some of those common shapes. The one that I want is the little plus or cross symbol. It happens to be on the shape tab, this one called the cross. To use a sketch from the palette, you just find it, grab a hold of the sketch, drag it onto the screen, and it's going to bring that geometry into your sketch. I'm going to let that snap to my center line right here, finish placing that guy. Then we'll put a couple dimensions on the sketch. I think I'll turn the constraints off here. I want a dimension where that center line is to here. Let's make a dimension. Display that one. Let's put that value at about 70. Just want a nice even number there. Let's make the size of the short lines about 15. I think I'll make the total height of 50. So there's a shape that I brought in from the palette, got it the size I want. To help me draw a second shape that I want down below that, I'm going to add a center line to my sketch here, like this. Maybe put another center line down here. Now the other shape I want is just a rectangle. So I think I'll right click, go to my corner rectangle command. I'm going to start a rectangle about here, and then I'm going to drag that over until it lines up with the line above it, just like that. Then there's one more thing I want on my sketch. I want to tell the computer that this height of my lower rectangle, that 20 dimension, should equal this 15 dimension from the top. Or in other words, anytime you want two things in your sketch to be the same size, you can go to this equal constraint, pick those two things in either order, and then the computer is going to constrain them to be equal in size. So I want to make sure this line in the bottom sketch is always equal to the length of that line up there. Then for the bottom sketch, I want one new dimension across here. We'll make that 70, just like the top. So there's a sketch of some geometry, and now I'm going to offset inside of that. Now I can have two disconnected regions like I do here, as long as the regions are closed, which they are. So I'm going to offset both of those regions at the same time. Let's go ahead and finish the sketch. And now we can see the computer is offsetting those to the outside. Now we didn't look at this one yet, but I can flip that direction and offset them downward instead of upward. I want these guys to be recessed into that top surface. So I just flip the direction of the offset. Let's offset it down about 3 millimeters like that and finish the feature. So now I have that shape. Now let me go back into that sketch really fast and show you why I'm about to build a separate feature. You're going to ask, why didn't I just do this in the original? Well, if I go back to this sketch and edit the definition of it, I want to put some text in here. But notice when you're in the offset feature and you go to a sketch, they gray out the text command. They don't let you build text in an internal sketch with an offset. Just a limitation of the software. So although I want some text, I can't sketch it in an internal sketch to the offset. So what I'm going to do instead is just make a sketch ahead of time. Then when I get into the offset, I'll be able to project that sketch geometry into the internal sketch of the offset, if that all makes sense. So let's grab this plane up here. Let's make a sketch on it. And now, since I'm just in a standalone sketch feature, I do have the text command available. So I'm going to go in and draw some text. We'll make a line to determine how big the text is. Let's choose a font. I think I'll use this bottom one. And then for my text, I'm going to type a word. Got about a 50% chance of spelling it right. So I want that to say volume. And I also want it to fit on the part. So now that I have my text, let's change a couple numbers. Let's make the height of the letters 24. To center those, we'll make this offset dimension 12. And let's make this one further to the left, about 74. I think that fits. It does. So now we have a sketch with some letters in it. I now want to offset those letters. We're going to raise those. The plus and minus were recessed. The letters are going to be raised. So now I just need to come back with another offset using that expand command, where I expand inside of the sketch with the letters. So we're going to take that surface, that's the one I want to expand, go to my offset command, just like before, we switch it to an expand here. And then under options, we want to do a sketched region. Define the sketch, I can use the previous sketching plane. And now, even though the text is grayed out, I don't need to draw text because I already have it. All I have to do is project the sketch that I made previously. So I go to this project command, we'll use the loop option, and now I'm going to grab all the loops here. Of course, the O has 2 loops. I need to pick both. All the other letters have 1 loop, so I just pick one piece of every other letter. And now I have a sketch inside of my text. The computer is going to offset just inside of it. So I go ahead and finish that sketch. I do want this one coming up, so I set the offset direction to be up like that. If we look at a front view here, right now, let's go up further, so just so we can see it better. Actually, I want a right view. And I can see my letters, the side of the letters, are normal to the sketching plane. I actually want those normal to the surface I'm offsetting. So we'll switch that normal to surface. And then I want to come up just 3 millimeters like that. So now I have some raised letters. Also, when I did the plus and minus, I left those sidewalls normal to the sketching plane. I've decided I want those normal to the surface as well. So we'll edit the definition, make those normal to the surface as well. Okay, now the sketch I used to cut the letters, I don't need to see anymore, so we hide it. Let's turn our shading back on. And there's our little, like bumped up button for our volume control. Now, just to maybe show you a little more seed and boundary, maybe I want to apply some colors here. Maybe I want to color all the surfaces of the bump there. So I think what I'll do is pick one of them, hold my shift key, pick this surface here as the boundary, let go of the shift key. That picks all the surfaces of the button. So maybe I did that because I want those to be a darker gray. Then maybe I want to color the volume letters a different color, including the side surfaces. So if you count all those, there's a bunch. So I think what I'll do is pick the top one, hold the shift key, pick this as my boundary. Then maybe I make those white. Just for fun, let's color these surfaces too on the recess. Maybe make those blue. And then while we're at it, let's grab the last surface on the outside, maybe make that red. All right, so anyways, there's an example where we did a bunch of those offsets inside of a sketched region using the expand. Now, that expand feature works on surface geometry like we looked at here, or on that previous model, we saw that we could take an entire solid face and we could expand that as well. So one more example. Now, when we're putting text onto a highly curved surface, we might notice a little phenomenal or situation where the computer kind of distorts your text, especially if we're on a very steep angle. So let me just show you one more example where putting text onto a highly curved or very steep surface might not really give you the shape you're looking for. So let's go to one more part here. Now, first thing I want to do on this solid model is cut in as a recess my little recycling logo. So I've already made that as a sketch. I want to cut that into this surface. So I'm going to grab that solid face, do my offset command, and we're going to switch that to an expand. And then I want to expand inside of this sketch as a recess. So I flip it into the part. Now I have that recess shaped cut into my solid part. Now, to take a look at a little bit of text, I'm going to project it onto this very curved, slanted surface. And I'm going to see that that projection makes a very distorted looking letter. Then I'll show you a feature that fixes that. So one more example here. Let's go to this plane up here. Let's draw a sketch on it. And now I'm going to put some text into that sketch. For my text, I can use the text option. And we're going to start by drawing a line. This line determines where the text starts, the lower left corner of it, and then how tall the letters are initially. Now for this text, let's pick a font that we want, like this one. And then for my recycling symbol, this is high density polyethylene. So there's the abbreviation. And then for some dimensions, let's make the height of the letters about 3/4 here. That'll fit. Let's make that dimension about 2 1/4. Let's make this more centered. Oh, about 1.3 maybe. All right, close enough. So there's a sketch of some letters just on a plane. Now, if I attempt to take those letters and drop them down onto this very curved, slanted surface where I'm at a big angle. Now, this is highly exaggerated. That's a huge angle there. But these letters are going to be very distorted going down onto this surface here. So let's go ahead and try it. I just want to show you the shape that we get. I want to do an offset or an expand inside of that sketch. So we grab this solid face again, go to our offset feature, switch the offset to an expand, and then I want to expand inside of a sketch that I'll put on this plane. Now I'm going to trace over those letters. Just like we did that previous time, we'll use the project as a loop, and we'll grab both loops of these two letters. So we're going to offset just inside of that sketch. Now, since I'm dropping it onto a very steep angle there, we're going to see that my offset really, really stretches out the letters. Now, I do want normal to surface here. And we get some very strange looking letters. So especially if I compare that to the original letter, they're way, way stretched out. So as it drops down around that curvature, the projection that my sketch is doing is causing these letters to get very stretched out. So of course, I don't like that shape at all. Now, highly exaggerated because I have a huge angle here. If I were to sketch on the front plane, it would not be nearly that distorted. But anyways, there is a way to avoid that. So instead of just using the original sketch to do the offset, I need to incorporate one more step. I'm going to delete the offset here. Here's the magic. So instead of just using the original sketch to do the offset, I'm going to first take those letters and I'm going to drop them onto this surface. Not with the project though. There's a similar command to a project called a wrap. Now, projecting something is like taking whatever it is you're projecting, do an imaginary extrude normal to the surface you're projecting normal to, and then look at where that imaginary extrude intersects your surface. That's what the project does. This wrap is more like thinking of the original sketch as a piece of string with a fixed length. You're going to take those pieces of string with fixed lengths, and you're just going to let them fall onto the surface. So in the original sketch, if that was a 1-inch line there, when I wrap it onto this surface, it's still going to be 1 inch long. We saw that when we projected it, it was about 3 inches long. It made it like 3 times longer. So the one step to not distort my letters here is to add this wrapping first. So what we're going to do is we're going to take that sketch, go to our editing menu up here, and do this thing called the wrap. And the wrap, again, just thinks of that original sketch as a piece of string or 20 pieces of string with a fixed length, and it just lets those pieces of string fall onto that curved surface. So now I have a template that I can trace around to do the actual offset where I cut into the solid, and it doesn't distort the shape of the letters. So to do the actual cutting, we're going to grab this solid face here, do an offset, switch it to the expand, and then we want to offset inside of a sketch region. I do have to make a new sketch here. So that new sketch will be on this plane. And now I just need to trace over those letters. So now I can see that's the shape of letter I needed. So I need a very funny shaped letter in my sketch to get a correct shaped letter on that slanted surface there. So we'll go to our project command as a loop. We'll grab these letters or these shapes. I actually got to pick the right geometry here. Oh, my computer's hanging up on me. So once that all comes back here, we will get this project to work and finish this guy off. Computer's cooperating again. I'll eventually pick the right thing for you. One more loop. There we go. All right, so now I've traced around these very, very funny shaped letters that I produced by wrapping, and that's it. So I go ahead and finish that sketch. We'll raise these letters normal to the surface, not the sketching plane. And now I've actually made the raised letters with the shape I want, and there we are. Let's hide the wrap, get that blue curve out of the way, and there we go. Okay, that's it. So what we looked at was the offset feature, but we looked at 3 options. The standard offset, which just takes the surface and offsets it. Then we looked at the expand, which either offsets or translates the surface and then fills in with continuous volume between them. Then, if you want to take that expanded volume and add draft to it, there's the expand with draft that we looked at.